Hello dear friends, and welcome to this video today on our YouTube channel. In this video, friends, we shall be looking at the correction of the 2015 advanced level physics question 2. So friends, watch the video from start to finish, because at the end of this video you shall be able to solve any question that is based on uniform circular motion. So friends, the question was based on uniform circular motion, and there are some important applications that the question has. So friends, like I said, if make sure you watch the video from start to finish, so that you're going to have a mastery of the concept. So friends, please for a quick reminder, if you're new to this channel, don't forget to hit that subscribe button, friends, and like the video, friends, because it took me quite a lot of time to actually prepare this video and deliver it to you both today. So friends, the only way you can appreciate me is just by clicking the like button. That goes a long way to motivate me to fuel my abilities of producing good content like this. And friends, don't forget to be part of the family by simply subscribing to the channel, so that you're going to have all latest updates about the contents that we create here. Thank you very much, guys, and let's dive straight into our video today. So friends, as you can see the question displayed here on screen, the question reads that a girl swings a stone of mass 100 grams at the end of a string in a horizontal circle of diameter 80.0 centimeters above her head. Her friend, observing the action, sees the shadow of the motion of the stone on a nearby wall and notices that the stone makes 150 revolutions in 5 minutes. We should calculate the frequency of the motion, and B, we should calculate the centripetal force on the stone, and C, we should sketch a distance time graph for this motion of the shadow for 2 circles. Great. So friends, this is the equation that we have here, which has been displayed on screen, friends. So as usual, friends, I'll highly encourage all of you to please pause the video and give it a try, then unpause the video to check the solution. Great. So friends, let's start by seeing a sketch. Okay, let's start by just seeing a picture of it. We're being told that that the girl swinging this stone, right, that the stone made a horizontal circle, right, because the stone was swinging in a horizontal circle. And we should know that the tension in this case, if the stone is being swung in a horizontal circle, guys, the tension in this case is constant throughout the motion. Okay, but if it's a vertical circle, guys, the tensions throughout the motion is not constant, like the tension at the bottom of the circle will not be the same like that at the top and at the side. Great. But in this case, we are being told that the girl swinged the stone in a horizontal circle, means the tensions in this case, guys, are constant. So we are going to have the circle that is being made of this form. So we're also going to have the stone, because the stone obviously is being swung around this circle. So the trajectory of this stone now is therefore a circle, because the stone is swinged around the circle. Great. Then we have a string of this form. We are going to put the string here to be vertical, to be vertical. Then friends, we are going to have the weight of the string, because this stone has mass, right? The stone has mass 100 grams, and therefore the weight of the stone, guys, has to be vertically downward. Keep in mind that the weight of any object is always vertically downward. So we're going to have an arrow, and we're going to call this mg, which is the weight, which is the mass times the acceleration to gravity. Then friends, what opposes the weight, what prevents the stone from leaving its trajectory, friends, is therefore the tension in the string, and that tension as components we have it as T. Good. Great. So friends, as we've inserted our mg, our T, it is left for us now to define all these symbols, because I told you guys last time that in physics, formulas or symbols are irrelevant if we don't describe them, okay, if we don't define them. So we need to define them. So we must tell them that where m is the mass of the stone and T is the tension force in the string. That's perfect. Once we've defined the symbols, now we are ready to use them. Okay, now friends, the question wants us to start by calculating the frequency of the motion. Keep in mind that the frequency of motion, guys, is simply given as the number of revolutions divided by the total time taken. Keep in mind, friends, that the time in this case is in minutes, right? We have to convert it into its standard unit, which is what? In seconds, right? So we have to convert that 5 minutes to seconds. So friends, it's super important to know that the frequency is given as the number of revolutions all over the total time taken. Great. So now the number of revolutions here have been given to be 150. Then the time taken to make this number of revolutions are what? 5 minutes. So we have to convert that 5 minutes to seconds, knowing that 1 minute is equal to 6 seconds. Therefore 5 minutes should be equivalent to 5 times 60. Great. So we insert everything, guys. We are going to have the number of revolutions be 150 like the question has given us. Then the time taken, we have 5 times 6 seconds. So if we punch down the calculator, guys, we will see an answer to be 0.5 hertz. Okay, frequency to be 0.5 hertz. So hertz is the unit of frequency, or you can write it as 0.5 revolutions per second. It's still accepted. Okay, so this is the frequency of the motion. Then now friends, the next part, if we are being asked to get the period of motion, because the question could still ask us to get the period of motion, we simply take 1 over the frequency, okay, which is the same like the total time taken over the number of revolutions, which is the same like 1 over the frequency. So once you have frequency, definitely you indirectly have period, because the reciprocal of the frequency gives you the period of motion. Good. So friends, the B part wants us to calculate the centripetal force on the stone. So friends, you might one issue that most students have is to understand the concept of the centripetal force. Okay, now guys, let me just give you a sketch. Note that a centripetal force is not a kind of force. We can say, for instance, if a question is asked you to maybe name 2 kinds of force, right? Don't ever say centripetal force, because centripetal force, guys, like I said, is not a kind of force. Okay, the centripetal force is always provided by another force. It is not like a standard type of force that you can just name it as a kind of force. No friends, no. The centripetal force is provided by a different force. Okay, so now the centripetal force, you know that it is always a center seeking force. A center seeking force in such a way that the magnitude of that force is always towards, or the direction of that force, guys, is always towards the center of a circle. Okay, the force prevents objects from leaving their trajectory. Good. Like for instance, the planets that are moving around the sun, what makes the planets not to leave their orbit is simply the centripetal force, and it is provided by the gravitational force in that case. Okay, but in this case, guys, we must tell them that the centripetal force in this case is provided by what, guys? The tension force. Okay, it's super important. Great. So guys, let's move on to our question. We should get the centripetal force. So friends, note very well, note this particular concept. Okay, what I just said now is the physics, so we have to tell them the physics, guys. This point is super important. It's super important, so you should take note of it. If a question like this is being given, guys, this point I'm about to give now is very important. You must have to include it, because that is what will tell the examiner that you actually know the physics. You're not just jumping straight to the maths, you actually know the physics. So you should tell them that the centripetal force is provided by what? The tension force. Great. This is what they want to mark before any other thing you're saying or beneath this sentence. Okay, this is what they want to see, because this is the physics of the problem. Is the physics of the problem. So friends, don't forget to subscribe to the channel and like this video, friends, because that is going to motivate me. That is to tell me that you found the content so useful, guys. I always get motivated each time I see many likes to produce more and more content, guys. So please press that like button. Looking at you guys, it doesn't take anything to like the video, it doesn't take anything to subscribe, guys. All I demand from you is simply just to like the video and subscribe. That's just all, guys. Thank you very much. So friends, after saying this, now we know that the centripetal force is provided by the tension force, right? So we can now equate this tension force now to the centripetal force. We're now going to have our F to be the same like T, right? But friends, after we know our centripetal force is equal to that therefore means that our F in this case, guys, which is the same like the T, is the same like what? ME. Friends, keep in mind that this revolves in a horizontal circle, right? It therefore means that there is no motion in the vertical plane. Okay, since the stone moves around the circle just in a horizontal circle, that therefore means that there is no vertical motion of the stone. So vertical component of the force exerted by the stone, guys, has no value. Okay, or it is zero. Great, it is zero, friends. So, and since the stone moves around this horizontal circle and still remains in orbit, that is to tell you that the weight in this case is being balanced by what the tension force, which is the same like the centripetal force. So we can use Newton's second law of motion for a body of constant mass, that the force is given as the mass times the acceleration. But let's tell them that the acceleration in this case A is what the centripetal acceleration, which this A in turn is given as A equal to r omega squared. Okay, A equal to r omega squared. But we have to tell them what r and omega is. Okay, like I said, that symbols in physics are very, very important. Each use a new symbol, guys, you must define what it is. So we are going to tell them that where r is the radius of the circle and omega is the angular frequency. Perfect. Once we've said this, now guys, we are permitted now to use the symbols r and omega. So we should keep in mind that omega is given as what, 2 pi times the frequency. Okay, it's given as 2 pi f. That's 2 pi times the frequency. So if we plug in everything, guys, if we plug in everything here, that is this our acceleration into this formula, we're now going to have f to be equal to mr omega squared. Great. But friends, keep in mind the diameter of the circle has been given to be 80, of which we can use the diameter now to get the radius of the circle by simply dividing the diameter on 2. So if we divide the diameter on 2, guys, we're going to have 80 over 2, which gives us what, 40 centimeters. But we have to convert the centimeters to meters. Okay, and the mass is in grams, 100 grams. We have to take 100 grams and convert it to what, to kilograms by dividing by 1000. Great. So friends, if we divide the mass by 1000, we're going to have 0.1, and the radius we're going to have 0.4. Then our omega is 2 pi f. 2 pi is a constant. Our f is the frequency, which is what we have here already. So we are definitely just going to have 1 into 0.4 into omega squared. Omega is 2 pi times the frequency, all this quantity squared. So if we punch that so well, guys, in a calculator, we are going to see answer to be 0.39 newtons, to two significant figures. Great. So friends, this is what we are going to have. Okay, this is the answer to this is the centripetal force we're asked to find. Great. So friends, just leave it in the comment section down below if what you think about this question, and also leave in the comment section if there's something you don't understand and you want me to explain them more. I'm going to do so for you guys. Thank you very much, guys. Then now the next part wants us to sketch distance time graph for the motion of the shadow for 2 complete circles. All right, so friends, let's have our vertical axis. We are going to call that the distance in centimeters, since the distances in this case have been measured in centimeters as we have, guys. Don't be a robot to put meters. Though if you put meters, the beginners will not get mad at you. Okay, but it's also important to appreciate the sense of the question. Okay, appreciate the sense of the question. Then now we have the horizontal axis. We are going to call that the time in seconds. Great. Though the time in this case was given in minutes. Okay, it was given in minutes, but we are talking about which circles have been produced, and we note that that 150 revolutions have been made in 5 minutes. Okay, definitely one revolution has to take a very small time to be made, and that time was in seconds, not in minutes. So it is good to appreciate the sense of the question. So we now have the origin, we have as 0 at this point. Then our friends, we should know that this is a distance time graph. Most mistakes that students always make is that they always sketch that for displacement time graph, since they are very familiar with the sinusoidal nature of the graph. Okay, this is the distance time graph, and it is never 0 in this case. It's never 0. The distance keeps on increasing forever. So I'm not going to have it in this case, guys, because this is for one circle. Okay, the distance keep increasing forever. The distance is going to increase and reaches a maximum point. That is, it reaches the maximum point where it behaves as if it is stationary, and it still keeps on increasing again, and so on and so forth, guys. But if you've been asked to sketch a displacement time graph, guys, it is going to be a sinusoidal curve. Okay, it is going to start from the origin, hit this maximum point, come back, bypass the origin, goes down towards the negative y-axis, and so on and so forth. But in this case, we're being asked to sketch the distance time graph, so the distance must keep on increasing forever. So in this case, guys, this is just for one circle, okay, but we are being asked to sketch that for two circles. So I'm going to copy and paste multiples of this similar. Great, perfect, friends. So this is what we're asked to sketch. Okay, this is what we're asked to sketch. So friends, thank you very much for watching the video, friends. Thank you so much, and don't forget to subscribe to the channel if you're not subscribed, guys. If you subscribe to the channel, guys, you're going to have all latest updates about our content, because we produce videos in this channel every day in all the sciences and the art subjects, as well as the commercial subjects. So friends, don't forget to subscribe to the channel, like the video to have latest content. Thank you very much, guys, and have a blessed day.